So now that we've taken a look at Kruskal's algorithm, we could take a look at another approach to making a minimum spanning tree, which is Prim's algorithm. The idea of Prim's algorithm is pretty simple. We start at any starting point in our graph that we would like, and from that starting point, we pick the smallest possible edge. We then consider any edges that connect to our starting point and the node that we've connected, and we pick the smallest possible edge again. We continue this until we've built a minimum spanning tree. So to show you an example of this, in this graph here, I could start at 0, and then I need to pick the smallest possible edge between 8 and 4, which is obviously going to be 4, right? At this point, I can explore any edge that's connected to my graph so far. So I can explore this edge from 0 to 7. I can explore the one from 1 to 7, from 1 to 8, right? I need to determine which one has the optimal weight for me to pick, right? And you can see that there's two edges of weight 8, so I can pick really either of these, right? And for this purpose, I'm going to pick the one that connects down here. And you'll see that it doesn't really matter which one I end up picking, but for now we'll just go with this and say, we'll go from here, right? So from here, we could see that we could pick either 8, 11, or 7, or 1, right? 1 is obviously the minimal, so we'll pick this one, which connects us to 6. And again, we take a look here, we could use 8, 11, or 2. 2 is obviously the minimal, so we'll pick that one. Again, we're going to be picking between 8, 11, 6, 4. So 4 seems to be my best option, so I'm going to pick that, which bring me up to here. From here, again, we're continuing the same process. 2 seems to be my best option, so I'll pick this one here. And now we get into a little bit more of a choice, right? So we can see that we have one that has a value of 6, which is technically the minimum at this point. However, if I pick this one, it would create a cycle between 2, 8, 6, and 5, right? So I can't take this edge because it produces a cycle. So that one's eliminated, right? The next one that we have is 7, which is right here, which also creates a cycle, so we can't take it, right? Now we have a 7 over here, which we can take, so we're going to take that one since it must be the next best one. From here, you'll see that we have a variety of different options. We have this 8 here, which is connecting 1 and 2. However, it would create a cycle, so we don't take that one. The next lowest one would be 9, so we'll take this one, which takes us here. At this point, we've connected all of our different edges, so we have our minimum spanning tree. So 0 connects to 1, then connects to 7, 6, and 5. We then have the edge that connects us to 2, which connects us to 8, and then connects us to 4. So that's generally what our minimum spanning tree is going to look like approximately, right? And you'll notice that there actually are some differences in the way that we could have constructed this tree, right? This is one possible solution that we have available to us. The other possible solution that we had was we could have taken this 8 up here originally, which would have connected 1 and 2 together, right? And then we wouldn't have had this connection between 0 and 7. We would have been able to reach it, in a different way, right? It would have given us the exact same sort of minimum spanning tree, as in the weights would have been the same. It would have just been like a slightly different version of it, right? So you can see that Prim's algorithm does indeed construct a minimum spanning tree for us. So with that basic understanding of how Prim's algorithm is generally working, let's go ahead and take a look at the code to see how we can implement Prim's algorithm in our program.